a philosophical introduction about artificial intelligence. And so the title of my lecture, you have read it on the program as Thinking and Reckoning from Leibniz dream to the universal machine. Okay. And then I have a first question. What are the intuition that you associate with thinking and reckoning is thinking, reckoning. So my aim is a little bit to introduce why did we get to the point in artificial intelligence where we are today. Okay, where does it come from and what was at issue? And do you think when you think about something, do you think that you are reckoning? So scary? Okay. So if you ask what was at issue, how did it all begin? You can think that actually, since the Greeks invented logic and geometry, this idea that all reasoning might be reduced to a sort of computation or calculation has dominated Western philosophy. Okay, so here you see a picture of a French painter, Jacques-Louis David, and he is portraying Socrates drinking the hemlock. This is something you have already said. So Socrates is dying and he is using his own death to give a last lecture to his pupils. And Plato describes Socrates' death in all details in Phaedo, in the dialogue called Phaedo. And another dialogue in which he described this is called Euthyphron. In Euthyphron, we have the very beginning of Western philosophy, because Euthyphron, you know who he is? He is a fellow Athenian of Socrates who is going to denounce his own father for murder. So Euthyphron says to Socrates, this is my religious duty to do so. I'm going to denounce my own father for murder. And Socrates asks him, well, what is piety? If you think it is your religious duty to do so, then tell me what is piety. And Euthyphron answers, giving some examples of piety. And Socrates says, I didn't ask this. I asked, what is the essence of piety? What is the characteristic of piety that which makes all actions pious, that I may have it to turn to and to use a standard whereby to judge your actions and then of other men. So what Socrates is asking is, he introduced in Western thinking universality. Okay? Piety is something that is instantiated in pious actions. So he wants to have the essence of piety, that without which piety would not be what it is. So it is a term in philosophy because before, this is of course a generalization of philosophy, was sophistry. If sophistry was the art of winning competition to, well, good formed speech. So it was based on the art of persuasion. This was the best argument, was the winning argument. And Socrates turns and says, tell me what is the essence of piety. Okay, and this you can think as is a first shaping of the notion of algorithm. Give me a set of rules, then prescribe me from moment to moment how to behave. Okay, I'm not saying Socrates had the concept of algorithms, but it is in Western thought a first turn. Tell me, give me a set of rules, that prescribe how to behave. Yes? So, okay, the points before sophistry. So the best argument wins. And with Socrates we have, tell me what is morality, tell me what is virtue, tell me what is beauty, tell me what is intelligence, give me universal definition. Universal means a characteristic mark that all things that has these marks are example of the general object. So he introduces philosophy, generality, universality. Okay. So we come to Plato. Yes, Plato is a name that you know, but actually we do not have time to read all of Plato, but a couple of things we can maintain here. So Plato generalizes this demand of Socrates of moral certainty to an epistemological demand. So Plato asks to give explicit definitions of concepts. Okay. Now, in philosophy, we have two important distinctions. The first is the distinction between practical knowledge and theoretical knowledge, and the second is the distinction between nominal and real definition. So what is the first distinction? So you know how to ride a bike, yes? So this is practical knowledge, it is a know-how. Theoretical knowledge was at that time knowing that things are thus and so. So Socrates' point is that if you cannot translate your know-how into knowing that, yes, you do not have knowledge but just mere belief. Yet, so cooks, for instance, that proceed by tastes of intuition, and all poets, they have no knowledge. This is a sort of arbitrary fumbling. And this is the worst thing that Plato has done, to put away poets from philosophy. Okay. So he is asking, give me explicit definitions of the concepts. You have a nominal definition is just the stipulation of the meaning of a word, and real definition give the essence of something. What is the problem? So according to you all know what is an algorithm. So we have thought before, Socrates asks to give a set of rules that prescribe how to behave. Now, if Plato is asking for explicit definitions, okay, if you give a definition of a concept, you still depend on the meaning of the words. Look at this definition of gold. Gold is a soft yellow metal, highly malleable, and so on. So you depends on the meaning. But what Western thinking, rational thinking wants, is to drop meaning, to drop any reference to intuition. Okay, this is the attempt. So begin with Socrates. Now Plato says, I want explicit definition, but if you give explicit definition of the content of the concepts, you are still depending of meaning. That is, the account that you are giving is still not a pure cybernetic account, syntactic account. You are relying on semantics, on meaning, on content. It's okay? You see, what I want you to see is this turn of Western thought at the very beginning, growing towards the notion of algorithms, and the implementation is Turing machine. Yes? So Another step is then necessary, and this is the concept of logical form. And now with Aristotle, okay, the content is dropped at all. So Aristotle introduces the first kind of logic. This is traditional logic. So now I have a question to you, because otherwise it becomes too long. Do you know the syllogism Barbara? Okay. Have you ever heard talking of logical form? Could you try a rough characterization? Make mistakes, it is not forbidden. May I ask everyone, so everyone tell me what he thinks it is? Don't be scared. It's okay. Begin. Sergio, may I begin with?
Can you repeat the question, Professor?
What do you associate with logical form?
With syllogisms, when we are giving the depiction of something, comparing this to no number of sets. Like here, all men are mortal, men are set of a number of people, and all Greeks are men. That means the Greeks are inside this circle of men. And more or less, logic is comparing different sets of numbers, narrow or wider, making a depiction of their nomen.
Okay. I just ask you because I just want to know what you associate with this. May you go on?
Yes, I'd say like it's just trying to infer new knowledge about something that you actually are sure that it is.
Okay. May
You get something that is it's true, you can guess or achieve the truth.
okay. Near you? No. Okay.
Like look at database and you refer something new from what you already have.
Okay.
So what the view is that? I would say it's just recognizing and creating connections and just getting to know more about the rules of our world. Okay.
Yes, and near you?
I can think of when you give different statement, you try to find something in common, and same idea like we figure out the connection among those.
Okay. Stop here, because actually we are talking of dropping the content. Yes? We started with Socrates. We said there is a first understanding of the notion of algorithm. Yes? And then we said that Plato wants explicit definition, but the terms involved in the proposition are still important for Plato. Okay? And this is a first example of logical argument. Yes? The conclusion follows from the premises. So you have categorical sentences. All men are mortal is a sentence of the form subject, copula, predicate, where men and mortal are general terms. That is, terms that have an extension. They are sets. Okay? The sets of mortal things, the set of men. And what is saying here is this relationship. Can you hear me if I speak without microphone? Between the premises and conclusion, okay, does not depend on the content of the premises and conclusion, but just on the logical form. And the logical form depends from words like all, for instance, and are. And you see, I substitute there the general terms to letters. So M is the middle term, P is the predicate, and S is the subject. And what this horizontal line is saying is not that the premises have to be true, but this is just marking the logical transfer of truth between premises and conclusion. The test that is saying if the premises are true, then the conclusion is true. That is, there is no way to make the premises true and the conclusion false. Okay, so all situations that makes the premises true make also the conclusion true. So you are discovering nothing new. Okay, you are just saying that the conclusion follows logically from the premises. That this dependence is formal. That's why we talk of formal logic, because it depends only on the form of the premises and conclusion and not on the content. Yes? And so what you have here as the formalization, and this is a part of today artificial intelligence, then we set up the language and we set up the programming language, and so we drop content. Yes? So, and I'm trying to tell you at the very beginning there were these tendencies towards formalization already at the very beginning of Western thought. So if you look at the antiquity, right? So you have in the 4th and 3rd century before Christ two schools of scientific rigor. Yes, scientific rigor means that these two schools were convinced that they were doing science. Yes, and the one was the logic school that traced back to Aristotle, and the other one was the geometrical school, and textbook was Euclid Elements. Yes. So here you have the thinking and reckoning, logic and mathematics had not that much relation. Okay, so so think of logic and think of geometry. There's a two way of characterizing deductive reasoning. Yes, but in geometry there is not much attention on the form of proofs, whereas in Aristotle you have a lot of attention of what are simple inferential schemas. Yes? So now when Aristotle writes the posterior analytics, he tells us what is a theory. Look, what is here, can you see this here? This is the classical model of science as Aristotle has taught us. So what is a theory according to you? So a theory according to Aristotle is an instrument that allows to categorize a certain field of knowledge, field of experience, field of objects. Okay, you have certain basic concepts, yet these concepts must be immediately intelligible. Okay, they have to be simple. They are not in need of definition. Okay, pay attention to the fact that you cannot define you can define only something that is complex. You cannot define something that is simple. Okay, so this is an extra logical source that guarantees the intelligibility of the primitive concepts. An extra logical source, intuition. Yes? And then you have certain primitive proposition that tells you what are the properties of the objects and the relation between the objects of the field. And then you have two logical procedure, definition and demonstration, that transfer evidence from the basic concepts and from the primitive proposition to the defined concepts and to the derived propositions. So this is the classical model of science. And the most interesting thing is that although you have not much relation between the two schools, Euclid's elements are the most representative examples of what Aristotle has meant by theory, what is a science. For Aristotle, a science speaks of a realm of objects that are homogeneous, that are interrelated. Yes? So now what happens in the Middle Age is that the two schools, thinking and reckoning, logic and mathematics, have still not much interrelations. So these two terms in Latin, a trivium and quadrivium, are like two different degree programs, and logic was taught here and geometry in the other one. Okay. Then I come to a very important person, Descartes. Do you have heard the name of Descartes? Yes, some of you. So Descartes is the one who devalues Aristotelian logic. According to Descartes, it is not possible to give a purely formal account of inferences, but you have to identify a specific intuitive moment in each inferential step. Yes, so these are the two traditions. The one is the tradition that goes from Aristotle to Leibniz to Turing. It has the formalization side, and the opposite one is Descartes. So you cannot drop intuition when you give a proof. And now at the beginning of the 17th century, you have a certain change of perspective, and you can identify two different directions of research. The one from mathematics towards traditional logic, and the other one from logic towards mathematics. So what does it mean according to you from mathematics towards traditional logic? It means that logic is the paradigm of scientific rigor, and mathematics, if it wants to be a rigorous science, should be presented in logical form. So there are some attempts. So it is not important that you remember these philosophers, but the attempt is to present Euclid's element in syllogistic form. And this is not possible because to represent geometry, you need a calculus that is able to handle relations, and syllogistic is not. Okay, but it is interesting the first change of perspective that the two schools begins to have a certain connection. On the other direction is the direction that is important to us, and it is the direction from logic towards mathematics, that is mathematics is the paradigm of rigorous science, and logic becomes mathematical logic, what we have today. Yes? So, and the first that introduces this is Thomas Hobbes. Have you heard the name of Thomas Hobbes? He is a political philosopher, and he introduces the social contract theory. But Hobbes is a mathematician by training, and he is the one who introduces in Western philosophy the metaphor thinking is reckoning. Yes, and read what you say. By argumentation, I mean the computation. It's reasoning means nothing but reckoning. So this is the program. Reason is nothing but reckoning. But you have to tell what are the bits on which I am reckoning. And you have to work out this metaphor. What does it mean that thinking is reckoning? And the man who does this is Leibniz. And also Leibniz, I think, is a concept for you. So you have heard the name. So Leibniz works how the metaphor of thinking is reckoning on the basis of his knowledge of algebra in the 17th century. Could we read together one quotation? So Leibniz is 20 in this work. He says he's 18 because he's someone who is very proud of himself and is always praising himself for something. And he says, when I was 18, I wrote a booklet with the title On the Combinatorial Art. This is the beginnings of combinatorics, and discovered a sure thread for thought, admirable tool of true analysis, the corollary of which is the artificial language or general characteristics. So now what happens? So Leibniz has a program. First of all, what do you know of Leibniz? Try to get awake. I know half an hour is a long time. So what do you know of Leibniz? Besides the name.
He was mathematician.
Okay. Also.
Was he?
Yeah, but we know him as a mathematician. That's what I meant.
So Leibniz is a rationalist, In philosophy, we have a distinction between rationalists and empiricists, rationalism and empirism. Okay, you know that Kant later on wrote a critique of pure reason. So rationalists believe that there is knowledge independently of experience. Yes? So there is knowledge that doesn't come from experience. And he also thinks every question posed by pure reason can also be answered by pure reason. Yes? So Leibniz thinks if I take all concepts and divide them till the very last concepts, as I do with the 25 words of the alphabet, I can create with these 24 words every word in many languages with 25 Buchstaben, letters. Okay, so this is the idea. I decompose till I reach the simple concepts. I number them to a procedure that is analogous to prime number factorization. And then I have the Erfindungskunst, the art of invention, under control. Okay, so he says, then what do? I create an artificial language, an interlingua, that has to be certain characteristics, that has to be easy to learn, and that should express as far as possible. And then I solve all controversies by means of a calculation. And then you have it. I skip the quotation. If you want to, we can come to the quotation afterwards. But what he has is, I do the universal language, so symbols and syntactic rules for symbol combination. Yes. Then I need a calculation rule, inferential schemas, and then I need a database. And at that time, the database was the encyclopedia, all truths that were at disposal at the moment. And here the thing, if controversies were to arise, there would be no need of disputation between two philosophers and between two calculators, for it would suffice for them to take their pencil in their hands and to sit down at the abacus and say to each other, and if there's a wish, also to a friend, colleague to help, let us calculate. Yes, calculimus. And so you, hi,
One sorry.
it's okay. So if you, this is a way in which you can schematize Leibniz dream, so many problems of which Leibniz was thinking at the moment have deductive form. So this is what we met by the syllogism in Aristotle. Yes? Thus a certain conclusion follows from certain premises. And the idea was to code premises and conclusion in the universal language and then to give the symbols these premises and conclusion encoded to the calculus. And the calculus decides, yes, the conclusion follows from the premises. No, the conclusion does not follow from the premises. Now, you can read everything that the history of logic after Leibniz as attempts to realize either the language or the calculus. Yes, but I think you are aware of the problem of decidability. To get a formal counterpart for this part of Leibniz's dream, you need to wait till the 30s of the last century, of the 20th century. So to be able to say what does it mean that a calculus decides a problem, and that are problems that are not decidable at all, you need Turing and Gödel. Yes? Okay, so I will spend a little bit to tell you about those philosophers that tried to set up the calculus, and in particular, I will focus on the work of George Boole. Do you know the name? He introduced Boolean algebra and the logical connectives, the logical gates. So Boole was working on the base of the developments of abstract algebra and the 30s and the 40s of the 19th century. Yes? So what do you have there? You have that people begins to think that mathematics is no more the science of quantities or the science of magnitudes. But they began to abstract the algorithms from the possible models, the possible interpretation. And then to use the algorithms, the symbolism, to interpret fields that are different fields of objects. Yes, and what Boole does, he writes first of all two important books, of which, so if you learn the logical gates, you just know the symbolism, but you don't know where does it come from. Yes, he writes the mathematical analysis of logic, and pay attention to the subtitle. It says being an essay towards a calculus of deductive reasoning. So they are thinking that they are giving laws, that logical laws are laws of reasoning. And later on, he writes the laws of thought. And so I would like to explain you what does it mean to set up the calculus in Leibniz dream. Okay, so let us take a look at how Boole is working. So what he says is, I take the signs of operation of normal algebra and they substitute them with signs for whatever, okay? And just says that these signs are something that obeys to certain laws. For instance, commutativity, associativity, distributivity, and so on. So these are no more addition and multiplication, but operations, whatever, that obey to certain laws, okay? And then I set up the language. And this is always the first step. Roberto, do you need something? Do you need something?
No, I just misprint your previous talk slide.
Where? Here?
Yeah, the definition of distributivity with star.
Yes.
Yeah, the last star.
Yes,
Star is a
yes, sorry, you're right. Roberto Schatze.
Yeah.
So when I set up a logic, the first thing I do is that I set up the language. Okay, so he has some letters that he calls elective symbols, and then you have primary signs. So one is the universe of discourse, so the class of things under consideration. 0 is the empty class. V is a non-empty class, and X, Y, and Z vary over class. So one is the universe. This is it can be the set of people attending this class or whatever. So the set of natural numbers. So what is the universe is context dependent. And then you have this science identity is clear, and then multiplication of classes is the intersection in the primary interpretation. The addition in Boole is a partial operation, so you can add only classes that have no elements in common. So for instance, you can add cat and dog, but not cat and rat things, because the two classes are not disjoint. And then you have the complement, but also the complement is an operation that can be made only if y is included in x. And you immediately see that this principle holds under the primary interpretation. So the primary interpretation is in terms of classes, and then you have the interpretation as propositions. So x and y vary on the proposition, then you have Boolean logic, and then you have the interpretation of as arithmetic, but restricted to 0 and 1. Yes? And these are the axioms. So commutativity, properties of 0 and 1 are the usual one. Distributivity and index law, idempotent. And this is the laws that characterizes Boole's system and does not hold in general for arithmetic multiplication. This law is the characteristic and fundamental laws of the logical calculus. And these are the possible interpretation. So the classical interpretation is traditional logic. Propositional interpretation, you see, x and y is true. So intersection of x and y is the universe. Or x or y is true. When is the disjunction true? When either the first x and not y, or the second it's true. So you have propositional logic and the arithmetical interpretation restricted to 0 and 1. And this is an example that we can make if you want. So this little exercise you want to try. So this is the proof of the non-contradiction. Just simply yes. So I just write the index law. I take x and x on the other side. Then I substitute x. X times 1 is the same, and then I distribute. Okay, and this is an example of how the calculus work. So I prove the syllogism in Barbara. So this is the first premise, is what we saw before by Aristotle. Yes. So all x z. Yes. Then here I multiply both sides by y, and then here I use the second premises, epsilon yx equal y. Then here yx equal y. I substitute here, then I reuse the second premise, and I get the conclusion. And this is, the way in which was thought of the calculus. So you have certain propositions, okay, certain initial data. You translate them into symbolic equations, and you calculate. And this is a sort of symbolism as black box. Black box means that not all steps are interpreted. So the symbolism could be blind. You have not the requirement that the calculation must be interpreted in each step, but then you have a resulting equation, and then these can be decoded. Yes? So what I'm trying to explain is this part here of Leibniz theorem. So what does it mean that the calculus decides the controversies? Yes? So then afterwards, so you have some that set up the calculus, other like the Italian researcher Giuseppe Peano that set up or focused more on the language. I skipped this part. We can come back together in the next lessons. Gottlob Frege is the father of modern logic, and Gottlob Frege develops both the calculus and the language. But as I said before, to come to the question, how the problems that are not decidable, you need the theories of the last century, and you need Gödel's theorems. Also in particular the generalizability of Gödel's theorems, because Gödel's theorems were initially proved from the Principia Mathematica, but in both theorems you have the word decidable. So we can come to Gödel's theorem in the next lecture. So nowadays we have many equivalent mathematical model for the informal concept of computability, lambda computability, general computability, mu computability, S computability, Turing computability. This is all courses that I teach here at home at SIT. Okay. And so, and then you come to this final step of the Turing machine, to the problem of decidability. And Turing starts from the analysis of the calculation carried out by a human computer with pencil and paper, step by step, on the basis of certain initial data. In the next lecture, we will see how Turing machine works, and we will do some practical exercise programming Turing machines. So this is one version of a Turing thesis. Yeah, it is a thesis. Of course, every Turing machine is the immediate rendering of an algorithm, but that each algorithm can be rendered by a Turing machine is a thesis, a conjecture that can be affirmed or confirmed by the equivalence of the formal counterparts given to the intuitive notion of decidability computable functions. So in the last step, Turing, if you think of a Turing machine, but this will be clear in our next lecture, it is a finite list of symbols. So it is not only that you give an input and you have the program and then you get an output, but you can think of the program as a finite list of symbols. Then you have a certain homogeneity between program and input-output. So the execution of an algorithm on a certain input has itself an algorithmic nature. So Turing talks of general execution algorithms. So we came to the Universal Turing Machine, and our computer do not perform one task at a time, but many tasks parallel. So I think we can stop here for this first lecture. I answer to your questions, and we can come back to Leibniz program or to Turing machine then the next time, okay?